Understanding decentralization. In this section, we delve into the concept of decentralization, a fundamental principle underpinning blockchain technology. Decentralization is pivotal in differentiating blockchain from traditional centralized systems and understanding its benefits and challenges. Centralized versus distributed systems. Centralized systems, these systems rely on a single point of control. For instance, most traditional banks operate on a centralized system, where all transactions and data are controlled and processed by the bank itself. This central authority has complete control over all operations and data, making it a single point of failure. Decentralized systems, in contrast, decentralized systems distribute control across multiple points. No single entity has complete control, reducing the risk of a single point of failure. Cryptocurrencies like Bitcoin exemplify decentralized systems, where transactions are verified by a network of nodes rather than a central authority. Distributed systems, these systems spread data across multiple nodes to ensure redundancy and reliability. While all decentralized systems are inherently distributed, not all distributed systems are decentralized. A distributed system becomes decentralized when control and decision-making are also distributed. The role of decentralization in blockchain. Decentralization is the core feature that makes blockchain revolutionary. It ensures that no single entity can control or tamper with the data, enhancing security and trust in the system. Decentralization is achieved through the use of consensus mechanisms, which require agreement among multiple parties to validate transactions and add new blocks to the chain. Benefits of decentralization. Enhanced security. By distributing data across a network rather than storing it in a central database, blockchain minimizes the risks associated with data breaches and cyber attacks. Increased transparency and trust. Every transaction on a blockchain is visible to all participants, ensuring transparency. This visibility helps build trust among participants, as every action is verifiable. Reduce censorship. With no central authority to control the network, it's incredibly difficult for any entity to censor transactions or data on a blockchain. Challenges of decentralization. Scalability. Decentralized networks can face scalability issues due to the consensus process, which can be slower and more resource-intensive than centralized systems. Energy consumption. Certain consensus mechanisms, like proof of work, require substantial computational power, leading to high energy consumption. Complexity and usability. The decentralized nature of blockchain can make it more complex for users to understand and interact with, potentially limiting its mainstream adoption. Examples. Bitcoin, the first decentralized digital currency. Bitcoin operates on a global network of computers that jointly manage the ledger and transaction processing, removing the need for a central authority. Decentralized finance. Platforms like Uniswap and MakerDAO operate on the Ethereum blockchain, offering financial services such as lending, borrowing, and trading without the need for traditional financial intermediaries. Decentralized autonomous organizations. These are organizations represented by rules encoded as a computer program that is transparent, controlled by the organization members, and not influenced by a central government. DAOs operate on blockchain technology and are an excellent example of decentralization in practice. In summary, decentralization is a key element that provides blockchain technology with its unique characteristics of security, transparency, and resistance to censorship. Understanding this concept is crucial for grasping the full potential of blockchain and its applications across various sectors.